For this next problem, we are asked to find the zeros and graph. Remember that finding zeros is the same thing as finding solutions, roots, or x-intercepts. And so in order to take this function and solve it, or find the x-intercepts, find the zeros, we need to set f of x equal to 0. So our y is equal to 0 when we have solutions, when we cross the x-axis. So everything else will stay the same in this step, but we are just setting our function equal to 0 so that we can solve. So we're basically making it the way that the problem before was already set up to be. So set f of x equal to 0. Now we are going to continue to factor and solve. I see that I can pull a 2 out as a GCF, but that's it. Or actually a negative 2, since I have a negative 2 here, and I'd like to have just a 1 in front of that x to the 4th if I can. So let's pull out a negative 2. That will leave me x to the 4th minus 8x squared and plus 16. Again, I'm pulling out a negative 2, so now I have factored out a GCF. I notice that I have 3 terms. That means that I'm going to use quadratic form next. It's quadratic form. We don't actually have a quadratic, we have a quartic, but because we have 3 terms, we can use the same format. So I'm going to say that 0 is equal to negative 2 and set up 2 sets of parentheses. But instead of putting an x in the front of each parentheses, I need an x squared so that I account for this x to the 4th. X squared times x squared will give me x to the 4th. Now I'm looking for 2 numbers that multiply to be 16 but add to be negative 8, and that would be a negative 4 and a negative 4. So now I need to look at each piece and see if I can factor further. This is a monomial factor, can't be factored anymore. This is a quadratic, and it happens to have a negative sign and 2 perfect squares. Difference of perfect squares is coming up. Notice though that this one is the same factor, x squared minus 4, so I'm actually going to do difference of squares twice. So difference of squares, and it's going to be twice, 1 for each of those pieces. So let's see what that looks like. I'm going to have a 0 and a negative 2. And now difference of squares for the first parentheses right here, x squared minus 4. I'm going to put x's in the front, 2's in the back. 1 gets a plus and 1 gets a minus. But now I need to do the same thing for this one. So I am again going to do 2 sets of parentheses, x's, 2's, plus, and minus. Now I can clean this up and simplify it because I have some repeated solutions. So negative 2 times x plus 2 squared, because that one happens twice, and x minus 2 squared because that one also happens twice. So this is my simplify step. And then finally I'm going to solve, or set each piece equal to 0. All right, well, if I set negative 2 equal to 0, that doesn't make any sense. In fact, if you wanted to think of it this way, you divide both sides by negative 2, and 0 divided by negative 2 will still be 0. So let's do the other pieces, the ones that actually have variables to solve for. So I'm going to say x plus 2 is equal to 0 and x minus 2 is equal to 0. This will give me x is equal to negative 2 and x is equal to 2. Remember that each of these solutions was a repeated solution. I'm going to say RS for short because I had a squared here and a squared here. They happened 2 times. Now let's look at doing a sketch or of our polynomial on just a rough graph that I've set up. In order to sketch, we need to know some of the same information that we previously did back in our graphing polynomials lesson. So I want to determine if my degree is even or odd and what my lead coefficient is. and then see from those what directions my arrows are going. So my degree for this is even. I see a 4. And so I'm going to note that the degree is even. The lead coefficient is -2. It's the coefficient in front of my degreed term, my leading term. So that -2 is a negative leading coefficient. Remember that the lead coefficient tells us what happens on the right-hand side of the graph, and so the right is negative, it's going down. Even says the left has to be doing the same thing. So let's go ahead and plot some points. I know that I have solutions, or I cross the x-axis, touch the x-axis in this case, at x minus 2 and x at a positive 2. I also know one more bit of information. The -32 right here, remember that that is always going to tell us what our y-intercept is. Now this is not going to be to scale, but I'm going to go ahead and put a point down here and say that that is -32. So the scale of my y-axis is definitely a lot more condensed than my x-axis. I know that I start with an arrow going down and I end with an arrow going down. I also know, because my repeated solutions were raised to an even power, there's a 2 here and a 2 here, that my graph bounces off the x-axis at those points. So given all of that information, I can sketch a graph. I know that I start out with an arrow going down. I'm going to come up 2, but then turn right here at the x-axis. I have to hit -32, and then I'm going to come up here and turn again to go back negative. So that is a rough sketch of my polynomial.